mostly is me, but still. Okay. Anyway, yeah, this is how it works. So if we want to go the other way, let's see, radians to degrees. It's actually a little bit easier. So let's say we had like 3 pi radians. How many degrees is that? So you could just flip the converter upside down, like divide out the radians and multiply in the degrees. But yeah, Grant remembered. The easier way, if this helps you remember because they're like almost identical, you can do it like this. But really all you're doing is you're changing the pi into 180. That's kind of what happens. Because remember that pi radians is 180 degrees. So this would be 540.
Did you think that you would have said
No, this one goes pretty quick. It's like
those TikTok Rizzlers.
okay. So you guys could use those formulas that I just put on the board, but also if you turn back a page to 259, there's 3 circles. They have a lot of the answers inside those circles.
Yo, for the question?
Yes, yeah, you guys see where I'm looking?
No, I'm just doing the questions. I'm already done.
Okay. So on number 1A is 315 degrees. We're changing to radians, leave answers in terms of pi. 315. I don't know if I can describe this easily. So you can just use there's like 3 ways you can do it. You can use the converter, which is times pi over 180. Let your calculator like reduce those two. Or you can turn your book back and look for 300. Turn back 1 page and look at 315. That's probably the fastest way. What do they have for 315? 7 pi over 4. Anyway, it works either way. The other way is just to recognize that, it's a little too hard to explain. The other way is maybe not as useful for you guys.
So we can use the converter on all of these?
Yeah. Said it's quick and easy, yeah.
If there's a negative, do we just make the
Yeah, if the degrees is negative, the radians is going to be negative. Same thing. So B is 225. Should I do all these and let you guys do it? Maybe I should jump ahead to when it doesn't match the chart.
No.
Yeah, jump ahead to number 9.
No. Why did everything else so bored? Okay, great. What is serious part of that?
I'm not saying it's one of them. I should still edge.
Oh, forward.
Okay, I'm maybe gonna do number 1 and jump. I'm gonna jump after that. These are too easy. Oh, 1C is not on the table that they made. So how am I going to do 15 degrees? What do I do to it?
Times pi over 180.
Times pi over 180. 15 goes into 180 like 12 times. So the answer is pi over 12. 15 is like 15 over 1. You guys remember reducing when you multiply, right? Reducing, negative 45. So D, positive 45 degrees is 1/4 of pi, 1/4 of 180. So this would be negative 1/4, so it's negative pi over 4. Yeah, if the degrees are negative, the radians should be negative. Same thing. Alright, now where am I jumping? 9? Yeah, I'm pretty sure everything else is on there. Probably. If it's not, just use the converter. Are they missing? Is there any weird ones?
Why is there stuff for like 40 inches?
Well, it gets weird once we get down to number 11 because those are just messy answers. So, yeah, I'll just start at number 9. Alright, you guys need to stop doing the evens so we can learn how to do number 9 too. Okay, number 9, the radians measure of theta. So we're supposed to be finding the angle on this one. So I wrote this formula, I don't know, 5 minutes ago or something, but the arc length is equal to the radius times the central angle, if this is in radians. Okay, if it's not in radians, we're gonna turn it into radians basically, so we can use this formula. Okay, that's the radians, this is the radius, and this is the arc length. Alright, so on 9a, they give us the radius and the arc length, so 5 and 6. 5 is the radius, the arc length is 6. So how am I going to solve for theta? 5 by 5. That's like 1.2 or 6/5. What did they put? They put 1.2 actually. Okay, that's 1.2 radians, which is, around 60 degrees-ish. A little bit more than that, actually. Probably closer to 70 degrees. All right, B, same thing. The radius is 8, the arc length is 6. So radius is 8, arc length is 6. So to solve, we're going to divide by 8. And we're going to get 0.75 theta. Linux got that song in my head. Linux.
What song?
I don't know what it's called. If the world was ending, is that what it's called?
If the world
I didn't ask
was
for it.
Die with a smile.
Die with a smile.
Lady Gaga's hot. Oh. And Bruno Mars.
Is she the girl that sings in that song?
Yeah. Bruno Mars is hot.
Montana's obsessed
They
with
call
her now,
anything
actually.
hot.
It's,
Who's they? It's just her.
It doesn't even have to be.
How?
It
Right.
could not even be a lot. I've heard some.
Take one look at a picture of Bruno Mars and say he's not hot, but
You said like.
he's so fine.
You can think that, but you don't have to just sit there and say it.
that could be a theme that Easton needs to learn. You think, don't say.
I do both.
Okay, on 10 it's, gosh, dang, that's loud. Gosh, man.
You have to do all the odds.
What level of Sigma are you?
Okay, number 11, where are we? Okay, 11 is just a mess. It's not going to be on the tables. So they say round it to the hundredths place. I don't know if I need to do all these either. Nobody.
Yeah, you should.
11 has this, like, I think it's milliseconds.
Oh, yeah. The last two are weird. Or no, just C is weird. Yeah, 11C and 12C are weird. Yeah, you actually remember seconds or minutes from last? That's actually minutes. You remember that?
Gosh darn it.
I'm surprised you remember it at all. Okay, anyway, to convert from degrees to radians, you want to divide out the degrees, multiply the radians. And this is a messy one, so we're not gonna, they want the answer in decimals, what we're saying. They want the answer as a decimal. So if your calculator spits out a fraction, hit the SD button, change it to a decimal, round it to the hundredths place. So this should come out as 1.66. If you round incorrectly, it will be wrong. Same thing on this one. I'm just gonna make you guys do it, but yeah. Okay, I will help see though. So Caden kind of remember this. Do you guys remember this? We barely touched on it last year. What does this thing right here mean? 10 minutes, which means it's 10/60ths of a degree. And if they go smaller, you could, like if they put something over here, this would be 10 minutes and 12 seconds. So this would be 10/60ths and 12/3600ths. So anyways, it can get messy. Do they do that? Do they do seconds? No, they don't. Okay, so our other book did seconds, but this one doesn't. So anyways, this is what we need to plug in the calculator when we do times pi over 180. Or you could reduce that to 1/6, of course. 95 and 1/6. A minute is a 60th of a degree, just like a normal minute is 1/60th of an hour. And D is not tricky. D is just a decimal point, 119.2.
Are A and B, are A and C supposed to have the same answer?
Oh, yeah, it's because 95 degrees and 95 degrees in 10 minutes is almost the exact same thing. So when you round it off, it's the same. It's not the exact same answer, but when you round it, it is. Okay, 13A we're changing from radians to degrees. They said to put it in decimal form and in minute form, but we're just going to do the decimal form. I don't really care that much about minutes. I do not think that's a necessary skill. But how do we convert from radians to degrees? Well, you divide out the radians and multiply in the degrees. So it's kind of it's like 11, but it's upside down. It's the opposite.
So this is where we actually need to use the formula thing?
And we're rounding to what?
So like we actually need to use the formula for this part?
Yeah, because there is no pi on these radians, you have to actually use that formula. It says rounded a 1/10 of a degree, so 13A they put 91.7 degrees. You guys know on your calculator you don't have to retype it every time, you can just go back and change this number, right? Alright. Okay, I don't think, is there any other tricks we need to look at? I signed, how far did I sign? 18?
You should take some more.
I'll do 15 and 16. No, 17, 18 are easy. Okay, 15 says, estimate by sight the size in radians of each angle shown below. Then measure each angle with a protractor. We'll just do this. And convert from degrees to radians.
We have to do all the
We
options.
should,
Keep it as a
yeah,
math.
we should skip 15.
Because we have to do all the options as well.
And all the A, B,
Yeah, but they take like 5 seconds each.
I don't agree.
yeah, actually, I like.
But he's like a teacher, so he's like
And
a-
multiple.
We'll talk about 15. So,
Bro.
So we don't have to do 16?
no, I'll make you do it too. Okay, so here's what we're going to do pretty close to what they said. I'm not going to get out the protractors though. How many degrees do you guys think 15 is? Let's do it that way. Probably 30. 45 is half of 90, so it's kind of like this. So that's a bit smaller. I would guess it's about 30. Let's see, based on the book's answer, we'll see how close we were. But then they wanted us to convert this to radians. So how do I convert this to radians? I think, and they wrote it as a decimal also. This would be like 0.51, 0.523. Yeah, that was a pretty good estimate because the book wrote 0.5. So we did pretty good.
Yippee.
Or I did pretty good. So on 16, how many degrees do you guys think that one is?
100.
Yeah, 100, 105, those are both okay. As long as you get close to the right answer. So on 16, you can just convert 100 or 105 into radians.
To the 10th place, or?
Yeah, they rounded to the 10th place, yes. Or wait, they rounded to the 100th place on that one, so.
That makes sense.
Let's see if you got exactly what the book got. See how close our guess was. Yeah, that is exactly what the book got. Yay! 1.75. So you probably got a little bit higher, right? Because you used 105. Oh, you did. Okay, 17. It says find two angles, one positive and negative, that are coterminal with a given angle. You guys remember this probably from, we did a test on this. So what's another angle that would stop at the same spot as 500? That's not 500. Yeah, if you add 360 or subtract 360, because 360 makes it go around a full rotation. So either way, it doesn't say. But since we're going to need a negative answer, I'm going to start going down 360. So if I drop 360 once, that's 140 degrees. Are you guys visualizing this in your head?
Yes.
So 500 degrees looks something like this. Like it goes around more than once because it's more than 360. So when you subtract 360, it kind of goes back and goes backwards, 360. So it would be just this angle from here to here, 140. But it stops at the exact same spot. And then if we want a negative angle, we just go backwards 360 again. And let's see, that would be negative 220. So a positive angle that would be coterminal is 140, and a negative angle is negative 220. So you just add or subtract 360 to get an angle that stops at the same spot. So B is negative 60. So to get a different positive angle that stops at the same spot, you add 360. And to get a different negative angle, you could subtract 360.
Is yours to convert the radians into degrees, or? Yours to convert the radians into degrees?
Oh no, if it's in radians, it's gonna stay in radians.
Oh.
So instead of adding 360, what do we need to do?
Add like
What's
2 pi?
360 is the same as 2 pi. So on C and D, we're going to be using 2 pi instead. You can let your calculator do it. You could plug in like 1/4 plus 2, but it should be like 9/4. So it's 9 pi over 4. And then of course, we need the negative version. So 1/4 minus 2 is equal to 1/4 minus 8/4, so it's negative 7/4. So negative 7 pi over 4. If you fear the fraction, you can use the calculator to help. All right. Oh wait, is that it? Oh no, there's D. Okay, negative 2 pi over 3 plus 2 pi. Okay, 2 over 1 turns into, if I multiply by 3, 6 over 3. So negative 2 plus 6, 4. -2 minus 6 is -8.
That wasn't bad for Wednesday assignment, right?